Okay, so today my internet connection is much weaker, so maybe we can lose connection again. So we studied about these chambers, and we are having four chambers heart. So these four chamber heart is a specialty of mammal. Mammals are those who produces milk. Those are mammal. Okay, those who produces milk and having hair on their bodies. Okay, they are like goat, rat, cow, dog, elephant, cat, humans, lion. Okay, another type of organism are known as aves. Aves are all organisms which are known as birds. Okay, birds are aves. So these two type of organisms are having four chambered heart. Okay, these are four chambered heart. Okay, and if you have seen that all these organisms uh, are active all year. Okay, they are active all year. It means that uh, you can see all type of birds all year, uh, in winters and in summers. In each of what is the weather, it doesn't mean, and what is the climate, it doesn't mean. They are active all year, and there is no problem when it is much winter or much summer. Okay, why? So because we studied that there is two type of separation, a left side and a right side, and these two sides are having two type of floods. We know this. Okay, one is pure form and one is impure form. So in this type of circulation, four chamber heart circulation, there is no mixing of blood. In this type of circulation, there is no mixing of blood, no mixing. Okay, so when these pure blood pumped to the body, it pumped in pure form and oxygen rich form. Okay, so these organisms which are having four chambered heart get pure blood always, pure blood always. That's why they will get a blood which is oxygen rich. Okay, and this oxygen is utilized to produce energy. We know this reaction, we know this reaction. Okay, so today I think my internet is very weak. So this, and they will produce energy. Okay, so this oxygen is utilized to produce energy. So in this circulation, the oxygenated blood is passed on to all of the body parts and utilized to produce energy. So as we know that in four chamber heart the blood never get mixed, and energy is provided to all body parts. Okay, and that's why the organisms which are mammals and ants, apes or birds are active all year, are active all year. What is the meaning of activation of all year? Think that if there are much winter, okay, or if there are much summer. Okay, so we need energy, we need energy to maintain our body temperature. We need energy to maintain our body temperature. Okay, to maintain our body temperature we need energy. So energy is produced in this type of organism in very good amount, because there is no mixing of blood, and this oxygen rich blood is passing to all over the body every time. Okay, so they are active in winters and they are active in summers. That is activation. Okay, because energy supply is very good each and every time. But in the organism which are having three chambered heart, okay, there is a mixing of blood. There is a mixing of blood. So what happens exactly, that due to the mixing of this blood, okay, these part is having CO2 and oxygen uh, rich blood both. Okay, both type of blood is present here, and that's why if this blood is carried to the organism, this generally happens in reptiles, okay, and fishes, okay, and amphibians. Reptiles are organisms which crawl like uh, lizard and chameleon and snake. Okay, fishes, you know, and amphibians are organisms which are present both in water and terrestrial life, that are like frog. Okay, so these reptiles and amphibians are having three chambered heart. Okay, so because they are having three chambered heart, the blood which is passing through them, their bodies is not oxygenated rich blood because there is a mixing, and that's why we cannot separate each and every part in oxygen pure blood and impure blood, so there is a mixed blood. Okay, that's why if there is a mixed blood, there is no proper supply of oxygen. And if there is no proper supply of oxygen, what happens exactly, that if there is no proper supply of oxygen, then they will not get full energy, because we know about this formula. Okay, we know about this, and there is no proper supply, so they are not getting proper energy. Okay, so we know that there are two type of seasons which hurts us most, winter and summer. Okay, so at that time they are not getting proper energy, so that they cannot maintain their body temperature. What about this, they are getting active all year, that means they can maintain their body temperature. If there is winter outside, we can maintain our body temperature inside. Okay, and if there is summer outside, we can maintain our body temperature. Okay, so we, this external temperature doesn't hurt us so much, because we can maintain our Okay, so today I think connection is very weak. So in both winters and summers, okay, for those organisms, those who are having three chambered heart like reptiles and amphibians, okay, so in winter season and summer season, they cannot maintain their body temperature, because the maintenance of body temperature needs energy, and they cannot produce very good amount of energy, because they are not provided with oxygen, very good oxygen, because their blood is getting mixed all the time. That's why in winter season and summer season, they undergoes in a position which is known as hibernation. If you have heard hibernation, in this winter season especially, okay, in this winter season especially, it is very difficult to find out reptiles like lizard and snakes. All of us have heard that they underground. Okay, because they cannot maintain their body temperature. If there is winter externally, they will feel a huge cold inside their body, and if this is summer, they will feel heat inside their body. They cannot maintain their body temperature, because they are not having proper energy, because oxygen is responsible for the production of energy. These are three chambered organisms, but crocodile is exception. Okay, and crocodile is a reptile, but it is exception, and it is having four chambered heart, so it never goes underground. It can maintain its body temperature in winter, and it can also maintain its body temperature in summer. So it never goes underground, it never goes in a position which is known as hibernation. Okay, now I'm talking about fishes. Now fishes are a bit unique. Okay, fishes. So fishes are having only two chambered heart, one atrium and one ventricle. Okay, and they purify their blood with gills. Okay, it is having one atrium and one ventricle, and there is a gill. These are gills. Okay, so gills helps to purify their blood, but say My internet is much weaker today. So all of the organisms which are having four chambered heart, organism with four chambered heart is known as warm blooded. Okay, warm blooded. Why warm blooded? Because they can produce energy each and every time, and the production of energy is something related with heat. So they are known as warm blooded. Okay, the organism which are having four chambered heart, because they can produce, they have free oxygen, no, sorry, their blood contain oxygen rich blood and oxygen less blood, but both of them are separate and they will never get mixed, so they can produce enough amount. Now in this case there is a mixing of both and they cannot produce enough amount of energy all the time. That's why they are known as cold blooded. Okay. Crocodile is an exception, and crocodile is also warm blooded, though it is a reptile, but it contains four chambered heart. You have to remember this. And the fishes exchange their carbon dioxide and oxygen with the help of gills, but fishes are having only two chambered heart. So fishes are also known as cold blooded, because there is also mixing. So any organism which are having less than four chamber, remember, less than four chamber, okay, less than four chamber are considered as cold blooded, because it is there is a mixing and there is no something pure. So there is a mixing, you can see there is a mixing then, and there is mixing of pure and impure blood. Okay, mixing of pure and impure blood. Okay, that's why they have no a very sufficient amount of oxygen in their blood, and if there is no sufficient amount of oxygen in their blood, they cannot produce enough amount of energy. Okay, so this is the concept. Now if you have any problem, you can ask me question, and I'm moving to another topic. This is a blood pressure machine. Okay, if you have any type of doubt, you can ask me, and I'm moving to another topic. You can interrupt me to ask if you have any doubt. Okay, so this machine is known as a blood pressure machine. Okay, blood pressure machine, and the name of this machine is known as sphygmomanometer. Okay, so some of you have experienced how do they take the pressure of blood. Okay, this is a scarf, and they bound it around our arms and they take the pressure. Okay, so let me tell you, this is the machine. Okay, and this was the machine which was used by old doctors. Old doctor means it is very old technology. Okay, now we are having digital machines, and these digital machines allow us to take blood pressure by own. We can use, a single person can take BP, okay, without any hindrance. So this is a new technology, but both of these machines are known as sphygmomanometer, and they help us to identify the blood pressure. So I'm just giving you an idea that how these blood pressure machine works. Okay, so this is you. Okay, and this is our heart. So I'm writing the four chamber, drawing the four chambers. Okay, and as we know that this ventricle, that is the left ventricle, pushes the blood to each and every part of our body, that is pure blood. Okay, pure blood is pushed by it. Okay, this is hand. Okay, so this is pure blood. Okay, so this scarf is used and which is tied on your arm. Okay, and there is a pressure of blood, and blood is pressurizing. So blood is going all through the body, but you cannot take blood pressure from your neck, obviously. Okay, I can't tie this on your neck. Okay, I can't tie this scarf on your neck. Okay, I can't tie this scarf over your uh, chest or stomach. That why we use this scarf on our arms. Okay, because our heart pushes the ventricle, left ventricle pushes the blood to our body, and the best side is that heart, that this arm, so we can take the blood pressure easily. Okay, now what happens that, remember that this is our arm, okay, and this is our artery which is conducting blood. Okay, there is a conduction of blood. Okay, the blood is going through. Okay, so this is my artery, our artery, and this is arm. Okay, so what happens that I told you that this ventricle is comparatively larger in size because it pushes the blood to all over the body through aorta. So this blood, when it comes down, or when it goes to our body, okay, and body, so it will create a pressure, it will create a pressure. Okay, there is a pressure, there is a pressure. Okay, so it will create a pressure. This is our hand. Okay, in hand there is artery. Okay, in hand there is artery. Okay, and blood is flowing in this direction. Blood is flowing in this direction, and it blood creates pressure in your artery because there is a pressure. Okay, so why this pressure came? This pressure comes because this ventricle is pressurizing the blood. Okay, so as this blood is coming out from this ventricle, so after this ventricle pushes blood outside, okay, it get contract. Okay, it pushes blood outside and it get contract, so it is known as ventricular ventricular contraction. As it pull all the blood outside, it will get contract or squeeze. This is known as systole. Okay, and again, when it will take blood from this upper part, because we know how the circulation of our blood works. So when it is getting something, so it is known as ventricular relaxation, and it is known as diastole. Okay, what is diastole and systole? Remember that I'm just writing about this. Okay, I'm just taking about this. So as it will push blood outside from it to go through the aorta and to all of the body parts, so it will get contract. Okay, it will get contract. This is known as systole. Okay, and after just this, it will get relaxed and the blood will come from this to this through this wall. We studied this. Okay, so as the blood come inside, it will get relaxed because it need to expand. We know that it will expand, so it is known as relaxation. Okay, it is known as diastole. So this, as the systole, and it is receiving blood, it will create the pressure against artery. This is the flow of blood. Okay, this is the flow of blood, and this flow of blood is creating pressure against this artery. Okay, and as we have placed this scarf on our arms, okay, so exactly what we are want to know, we want to know that the pressure is exerted by the blood. Pressure is exerted by blood, okay, on your arteries. Okay, so as we know that as this lower ventricle, left ventricle will push blood outwards. Okay, it will get contract and this blood will flow, will go in your arms with a flow, with very high flow. Okay, so the flow rate, we have to identify the flow rate, and at this time the flow is coming, this is known as, and it is same time it is creating a pressure against your arteries. Okay, so this is known as systolic pressure. Okay, and it is very high. Okay, but in another case, what happens exactly, that this is your hand and this is your artery. Okay, so at another moment the ventricle is relaxed. The why the ventricle is relaxed? because at the another time, this is ventricle, okay, it have pushed the blood, okay, but same time the new blood is coming here, okay, so it will get expand and relax, because at that time it doesn't need to flow blood, it is just receiving the blood. So at first case it is making the blood out, it is may let the blood go out, and it will push the blood, okay, and it will get contract, and at first condition it will get contract, okay, and its second condition when it is pushing blood out, okay, and in second condition it will get relaxed when it is receiving the blood, okay, when it is receiving the blood. So this is both these two things, okay. Now at that time the flow is very less, because there is finally we can say a very less flow, okay, and there is finally no pressure over these arteries, finally there is no pressure over these arteries. So at this time the ventricles are relaxed, so there is no pressure, okay, so no pressure is exerted by blood on arteries, okay, it is known as diastolic pressure, okay, when ventricles are in relaxed condition, it is known as diastolic diastolic pressure, okay. So the systolic pressure is measured in the terms of pressure, and the unit of pressure is Hg, okay, so it is always higher and it is 120, okay, and it is very less because there is no pressure, and there is when the at ventricles are receiving blood, so definitely they are not in mood to pass out blood out, so they are in relaxed mode, so it is 80. So generally we write our blood pressure that 120 upon 80, okay, this is upper value, and it is known as when ventricle get contract and they will push blood outside, so it is known as ventricular systole, and it is known as ventricular diastole when the ventricles are in relaxed condition and the ventricles are in contracted condition, okay. So this is how we can mm, uh, check our blood pressures, okay. This is the method, and sometimes this is the accurate value, okay, this is accurate value, it can be up and high depending upon the age, but if you are an adult, that means if your age is ranging from 16 17 to 50 55, okay, that should be very ideal, but it can change according if you having any disease, or the age is if you are elderly though, so it can get shift, okay, according to age. Okay, now what happens that sometimes this is our hand, okay, and maybe it is looking like foot, okay, but it is hand, okay, and this is your artery, okay, and these arteries are sometimes choked, these arteries are sometimes choked. Why they are choked? Because we eat sometimes very oily food and very fatty food, so it get choked, okay, and the flow of blood which will be very slow, okay, the blood flow will be very slow, okay, because it is choked, okay. So we know that it is choked because we have eaten so many type of unnatural food, fatty food, okay, so the blood cannot pass through it easily, okay. If something is very clear, the blood can pass easily, okay, if something is very clear, blood can pass easily, but at this time blood cannot pass easily, because what happens actually that this is chalked, this is clear, and this is chalked, okay. So at that time blood feels very much pressure, blood feels that I have something choked, or I don't feel that I can flow easily, because it is a very filled pathway. Okay, but at the same time ventricles are doing their work, and they are continuously, after diastole condition, they are continuously releasing their blood. Okay, there is two conditions, systole and diastole. In one condition, they push blood outward, and another condition, they receive the blood. Okay, so one time they are pushing blood outside, and at one time they are getting blood inside. So it will feel that the blood is continuously coming, but there is no space. Finally there is no space, and blood is continuously coming. Okay, after each systole, the ventricle will push blood outwards. So what happened, that blood is coming continuously, but it cannot flow here easily, because there is choking or fat deposition. So it will try to pass this artery very quickly, because there is a passage is not, ventricle is pushing blood continuously, but there is a less space, so it will try to run out from this space, because if it will stop here, okay, then what happens about the blood which is continuously coming? Okay, so it wants to flow with a pressure, so that it can pass easily. Okay, so it will create a pressure to pass from here. In this case there is a normal thing. Okay, it will flow with the normal rate. It is continuously coming from ventricle blood, and it blood will flow with normal rate. But at this time blood is continuously coming, but it doesn't found its part, so it tries to pass this particular passage, particular this choked part very quickly. That's why it flows with the pressure. Okay, it flows with the pressure to pass out from this choked part, and this pressure of blood is known as blood pressure. Okay, sometimes the blood pressure is also known as hypertension. Okay, so this is the reason of hypertension or blood pressure, that don't eat so much oily food, otherwise it can cause you blood pressure. Blood will try to pass this place so fastly, because if you want to go through something, or if you want to cross a pathway. Okay, if you want to cross a pathway and you found it that it is having so much something you cannot pass here. Okay, and you want to pass it. Okay, you want to cross it, and you think that flood is coming from this side. I cannot go here, I cannot go against. Okay, I have to go this side, but I am facing so much hindrance. uh okay, I'm just telling you about low blood pressure after this. Okay, so you cannot go back side, you have to go this side, but there is so much hindrance, so you will try to run out so fastly, because this particular region is not appropriate for you. Okay, so you will try to run from this place, because something is coming here deadly, something deadly thing is, you just need to move it from this pathway. Okay, you cannot go back, you need to go from this pathway, and this portion is deadly for you, or you think that this is not my appropriate pathway, so you just try to run away from this. Okay, so this running is creates extra speed, and that is known as blood pressure. Okay, now Saleh asked me what is low blood pressure. Low blood pressure is, this is your hand, okay, and this is your artery. Sometimes when your ventricles push blood outwards, okay, not with very good pressure, but it makes blood push out to aorta with very less pressure. Okay, it is not a very, don't think about that if I'm having any low blood pressure then I'm sick. Okay, it is very normal thing, most of us faces low blood pressure, so there is nothing bad, and you don't need to go to doctor that I'm having low bp. If it is much lesser, then it is the thing to concern. Okay, otherwise low bp and a bit high bp is not very dangerous things, no life threatening. Okay, sometimes you may feel very tiredness and very much weakness, fatigue if you are having low bp. Okay, but don't think it is not lethal, it is not a life taking thing. Okay, it is very normal thing, it is normal thing. Okay, it is not lethal. So sorry. Low blood pressure is something, it is a problem of ventricle. Okay, and the blood is coming down very very slowly, slowly. Okay, that is known as low blood pressure. Okay, I'm moving to another topic, and we are going to learn about two pipes we studied on yesterday. That in the heart, we know that we are having four chambers, and I told you that the left ventricle is comparatively larger because it needs to push blood. So we studied two things, that there are two pipes. Okay, these one pipe brings impure blood to our heart. Okay, and there is a pipe which originates from here. Okay, and which takes oxygen rich to all of our bodies. Okay, and this pipes a thicker pipe which is known as aorta. I'm drawing it very in this way. Okay, this is a very thick part. Okay, this is aorta, and this aorta is very thick. After some time, this aorta will bifurcate into small, very small pipes, and now they are known as arteries. Okay, and these arteries, again these arteries bifurcate in many tiny small pipes. They are much tiny, they are known as capillaries. Okay, they are much tiny, that capillaries are much tiny, that these are my blood capillaries, our blood capillaries, and they are so much tiny that only one RBC. Okay, do you know the size of our cell? You cannot see RBCs with naked eyes. Okay, the size of RBCs are in they are 1 to 5 mu. What is 1 to 5 mu? Mu is micrometer. When I this is 1 meter. Okay, then okay, if I divide 1 meter from this number, I will get 1 mu. Okay, so this much tiny is our RBC are much tiny. Okay, so in our blood capillaries are much small pipes of blood which can carry only one RBC in one time. That means this pattern. Okay, only one RBC can flow through them. So they again, arteries bifurcates or divide into tinier capillaries, so that these are our tissues and cells, so that you know how minute our cells are. Okay, so that the capillary can direct contact with these minute cell. You know, aorta is that much thick, you can see aorta. Okay, the aorta is that much thick, and the cell you cannot see this. Okay, the cell, I just dotted a cell. Okay, cell is much thinner, you much smaller, you cannot see it with naked eye. So this is the size of aorta, this is the size of aorta, and this is the size of cell. Is it possible that they can interact with each other? It is not possible. Okay, maybe you can see aorta, you can see aorta with naked eyes, but you cannot see a cell with naked eyes anyhow. Okay, so it is good that it will get divided into small cells, so that they can come within contact with each other. Okay, now you know they are bringing oxygen, and there is a reaction, and after the reaction, after the respiration, there is a production of CO2. Okay, now again very small capillaries. Okay, and they will, small capillaries, they are taking impure blood. Okay, and these will join together, many capillaries, small capillaries forms veins. Okay, so these veins are similar to these arteries. Okay, now so many veins, come together and joined into vena cava, we studied.